All right, bro, seriously. Let me change the video. Oh, there's so much that I need to organize.
Did you have a
Oh, yeah, I put one on your desk.
You're not giving me any information.
And then, at the end of the day, by saying like, oh, we went under.
Hey, everyone. Is this plugged in? Yeah, it's coming out.
We went to a place on a day. I'm not gonna tell you what we're doing.
Ugh. It's not very good. But anyways.
Wait, that's a really.
Of course. Oh, you need notes. Everyone, come on. What is pi to you? Yes. Huh? It's a number, absolutely. It's a constant. It's a number that does not change. And no matter what we do, that number is going to be fixed for all of eternity as far as we know. Anyone else? What can you tell me about pi?
Pi is 180.
Pi is 180. That means nothing. It's untrue. It's untrue. The way you defined it is untrue. I know what you're doing, but technically speaking, that definition is untrue. Shannon?
Used to calculate circumference.
Yeah, it's part of your formulas, right? So you when you were younger, you learned about pi r squared, 2 pi r. Heck did that come from though? Yes, Fiona.
Some ratio that has to be circle.
Some ratio, absolutely. It's actually a fraction. It's a ratio. It's a ratio. It's a fraction between two numbers where we can't find the end yet. Oh, anyone else want to comment about pi? Yes.
It gives people dementia.
What? Really? Dementia? That's the first time I've heard of it. Interesting. I would.
Please explain.
I would argue. It might give people anxiety, but dementia is one other thing. Let me put it this way. Pi, as Fiona was saying, is a ratio. Specifically, this is the ratio. And this is what I hoped up until a few, maybe a decade ago, when I realized it wasn't happening. This is what I hoped elementary school teachers did at least once in their students' lives. It would give them a piece of string. And they would say, okay, draw a circle, and they could get a compass and you draw a circle, a perfect circle. Take your piece of string and measure or put around the circle and tell me how long that piece of string is going to be. In other words, tell me how long of a distance is traveled when you go around your circle. In other words, again, tell me what the circumference is. And let's pretend the circumference was something like 3 centimeters. Or no, that's too small, like 9 centimeters. Okay, they drew a circle, they took a string, they measured around it, it was 9 centimeters. And then they said, okay, take your string and measure the distance from one point to the end as it goes through the center of your circle. In other words, what's the distance of your diameter? And they would have gotten something like, diameter was something like 2.9, let's say. Okay? And they're like, hey, you, what about you two? Like, tell another partner, okay? Chime in definitely. What did you get for your circumference and your diameter? And Chime, being who he is, maybe do a huge circle. And it's like, oh, my circumference was actually 25 centimeters. Okay. Well, what did you get for your diameter? You measure it and be like, oh, I think I've got about an 8. Okay. When you're younger, you sort of round. You're like, that's about 8 centimeters. Then you ask another partner. And they're like, well, what did you get? Well, it's like, my circle's not as big, so my circumference is about 20. Well, what's your diameter? Oh, I got about 7. Okay. Are you sure it's 7? Oh, let me check again. Oh, it's actually like a 6.5. I don't know, whatever. Okay. And you keep on trying. As you write more and more circumferences and compare it to the diameter, you will always see the circumference being quite large and the radius being a certain proportion of it. What proportion? About 1/3. So this diameter, you multiply it by about 3, and you always got the circumference. That's the magic number of pi. Pi, sort of like Euler's constant, it appears a lot of different places. And the easiest place to see is the circle. Draw any circle. Give me any circle. Look around you. Any circle that you see in this room. If I were to accurately measure the distance around it, so the circumference, and I compare it versus, if I compare it with the actual diameter, you will always get a certain ratio every single time. And people of old, as they made more of these observations, they realized, oh my goodness, it comes up every time. Let's give it a name because we see it everywhere. And so there it is. That's what pi is. It's not just a number 3.14 that you memorize. There's a relation, there's a reason for it. Okay? And so going back to this, there's a lot of different applications. Why am I talking about this? Well, you will see. So let's take a look at this, this sheet. I'm going to use the camera now. See if I remember what I want to say to you without making mistakes. And I would prefer having a highlight. So bear with me. It's my pen. And does Mr. Ross have nice highlighters? Perfect. Okay. So shoot. Pardon? Yes. Okay. So yes. So pi is a ratio of circumference to diameter, and you know that diameter could be rewritten as twice the radius. So it's virtually the same thing. And if you rearranged it, guess what? That's why your circumference has the formula 2 pi r. Or if your textbook was a little different, you would say pi d. Whatever works. Right? Depending on, like, you either have, pi times d as your circumference or pi times 2r as your circumference. Depends on your textbook. So far, so good, everyone? Right? So this is pi, and let me try to focus just a little bit more. Now we can actually talk about this thing called radians. Radians. Okay, you know that, okay, that I have with me a unit circle, so I could do this. Let's pretend it's, that's a radius equals 1. You know that a full rotation around a circle is how many degrees? 360. Good. And remember, this is a radius of 1. In terms of distance, how much did I walk if I walked around this circle? Remember, it has a radius of 1. Sorry, it has a radius of 1. So if I walked around a unit circle, what is the distance I traveled? Yes. Pi. So in other words, 6.28 units. This is like 6.28 meters, 6.28 centimeters. It doesn't matter. It's 6.28. Right? Look what we just established. Full rotation, they are the same thing. So mathematically, what did we just say? A 360-degree rotation is the same as walking 2 pi of a distance. With me so far? If that is true, what if I walked 180 degrees? So I just wrote 180. Oh, wait, right side? 2 pi units. I'll try to zoom in. So I don't. Does that help? You're right. So if I walked 180 degrees, in other words, half of 360, so if my angle was half of 360, the distance that I walked would be half of 2 pi. And then, yeah, just 1 pi. So what I'm trying to get at is, if you know what rotation that I walked, you can convert that to a certain distance that you walked. So radians is simply a measure of how much of the rotation, or how much of the circle that I walked. What's a good one? Yes?
Would it be different?
Yes, it would. So by then, so let me talk about these two statements. If the angle rotated is known, then the distance traveled can also be known. Agreed? Just like what we did here. If I rotated 360, I know I traveled this much. If I rotated 180, I know I traveled this much. And if the distance traveled is known in proportion to 2 pi r, or in proportion to what we did as unit circle, we can convert it back and forth to the actual distance or not. I know that sounds a little bit weird because I just sort of threw it in your face. Let's put it this way. So, example, if the angle rotated is 90 degrees, right? This is equal to, so 1/4 of 360. Then so Jamie, for your example, give me a number that's not a one. 4. Just as an example. Let's say usually be so that's it. This is the lesson. It's the idea. So that's why I wanted you to sort of have it and have a day to sort of chew on it. It's the idea that if I know the rotation, I can technically measure how much I walked as well. There is a relationship between the rotation and the length of my curvature. And the word we call that is an arc. The length of the arc and the rotation that I walked is related to each other. What is the specific relationship? Well, 2 pi to 360 or pi to 180. Yes.
What was the last word?
Oh. Unit circle, yes. Okay. So please note, we don't really care about when the radius is not a 1 right now. We'll actually talk more about it in 4.2. So you don't have to concern yourself. But to address one of the questions, like what if it's not a unit circle? Well, then that just means the circumference simply increases because the radius is not a 1. And so you would do the same thing. And because of this, we just work with 2 pi because if we know what the angle is in radians, then we can just multiply it with the radius later on. It's not something you need to concern yourself with. I will also show you how to do this later on as part of tomorrow's lesson. I just wanted to show you that angle in radians is exactly the same. Yes. Yep.
The ending. What does 1/4 or actually it's a 1/4
A quarter. So in 90 degrees, you could say it's a quarter of 360. In the same way, you can say, if we're talking about radians, a quarter of 360 can be converted and say it's a quarter of a full circle, a circumference. Okay. Mathematically, in case some of you are still not quite sure, or you want a foolproof formula to convert from degrees to radians, and I guarantee some of you will, what we're going to do is use a conversion factor of 180 to pi or pi to 180, depending on what you want to convert. Here's an example by going to the next page. You don't have to do all of it. I'm just going to show you, and then I will talk more about it tomorrow. Let's do, this is all exercise. It's just pure rote memory. So let's try, sure. Let's do 35. Okay, for part A, 35 degrees, I want to convert into radians. How do you do that? You are going to multiply with a conversion factor as if you were multiplying like seconds to hours, meters to kilometers, so on and so forth. 35 is going to be multiplied with 180 degrees on the bottom and a pi on top. So the degrees can cancel out, leaving you 35 pi over 180 radians or rad. But not very much simplified. So I'm going to try simplifying. I'm going to divide both sides by a 5. There. So 35 degrees is equal to a not so nice fraction.
That's 7 pi over 30.
Yes.
You just
leave it as that. That's how many radians it is. And if you put that in the calculator, that's how they would use it. Let's do one that's a little bit more, a little bit nicer. Let's take a look at C. 135 degrees. What is that in radians? Well, same thing. I'm going to multiply it with the conversion factor that has the degrees on the bottom, so that the degrees will cancel out. And this time, instead of multiplying out, let's just simplify first. What are some numbers that I can divide both 135 and 180? Sure. So this becomes 27. And this becomes 36. Can I go further? Sure. 27 divided by 9 is a 3. 36 divided by 9 is a 4. I have 3 pi over 4 radians. And that's it. I'm not going to go any further. We're going to do more of these examples after our mini test tomorrow. But the reason you might be wondering, why the heck would we use radians instead of degrees? It's strictly, in my opinion, semantics. There will be situations in your future where you have to talk about rotations, based on how far you walk. It's not angle. It's how far you walk, which is a measurement. And therefore, you'll be discussing it based on radians and not degrees. That's all. So you have to be able to go back and forth between the two. If you don't like radians, be super fast with this so you can convert it back to degrees. I highly recommend it. We'll see more of that next time. You have 5 minutes. Sorry, it took a little longer than I thought. But if you have any questions, please reach out to me. Your mini test, again, 40 minutes. We're gonna start with the extra time people first. I realize that sometimes the principal is outside and, sort of makes people wait until about 45, right? So we'll start on time right at 9 o'clock. And hang in there. This week is a shorter week for a lot of you.
How long?
Pardon?
How long is it gonna come?
It's hard to answer. Come see me. Yes. One second. Let me just stop here.